Welcome to our 10th Cosmos Rewind Google Hangout, sponsored by Celestron. We love Celestron telescopes, where the editors of Astronomy and Discover magazines dissect each episode of Cosmos' SpaceTime Odyssey. This past week's episode was titled The Electric Boy, and it covered electricity, magnetism, and the life of Michael Faraday for a considerable part of the episode. I'm Dave Eicher, the editor of Astronomy magazine, and I have with me again a very distinguished panel of folks who you may be familiar with. Let me introduce them before we get going today. Bill Andrews, the associate editor of Discover, is with us today. How you doing, Bill?
I'm good. Happy to be here, Dave.
Corey Powell, editor-at-large of Discover from beautiful New York City. How you doing, Corey?
I'm good. Hey, wait a second. I have to do my Neil Tyson. I'm here from New York City.
And Sarah Scholes, associate editor of Astronomy. Nice to have you with us again today. Sarah, how are you?
Good. I don't have a Neil Tyson impression, but I'm good.
But you
some people have it, some people don't.
But you do have a summary of this episode for us, which you're going to deliver about the life and times of Michael Faraday.
I do have that. So in this week's episode of Cosmos, which was the 10th episode, our friend Neil Tyson took us on a kind of journey into the strange world of electromagnetism and the occasionally equally strange world of one of its founders, Michael Faraday. Faraday grew up as a kind of poor kid with, at least according to the show, a speech impediment, and he didn't do well in school, like other of history's geniuses, but he did manage to become very interested in this phenomenon of electricity, and after he learned about the work of a scientist named Humphrey Davy and saw some of the public demonstrations and lectures that he was doing. So then Faraday managed to insinuate himself into Davy's life, becoming his lab assistant, and then kind of working on the same things. But then one day, Faraday discovered how to harness this electromagnetism and turn it into mechanical work, make a machine. And Davy was not too happy about this, usurping your mentor, not generally making your mentors happy. So Davy banished him to working on glass instead. But then after Davy died, Faraday hopped back over to electromagnetism, and in the course of this, he thought maybe these two things, electricity and magnetism, were perhaps connected by something that we couldn't exactly see. And he thought that they might have, he might be able to sense this effect and connection on light. But he didn't experiment with that I think we'll talk about a lot during this episode. But he had dropped out of school early, so he didn't have the math street smarts to be able to describe this and with equations. So then later, another scientist named James Clerk Maxwell came along and was able to turn Faraday's kind of abstract ideas about what was going on into cold hard variables, integrals, differential equations. So then the show concluded with kind of a touching conclusion in which Maxwell and Faraday are shown as, kind of discovering together this force that protects us from cosmic ray bombardment and also facilitates communication between all humans in the future, and allows us to have smartphones and Tesla cars and things like that. And then one of my favorite parts of the episode was a quote that I believe was from Faraday that says, nothing is too wonderful to be true if it be consistent with the laws of nature, which, yeah, it's a pretty good quote, so I can't really add anything to that, and I think I'll end there in my summary.
Well, thank you, Sarah. And before we get going here, I liked the episode in terms of how it treated its subject, but I have to say I was somewhat astonished again at how indirectly the series has covered astronomy, and particularly the huge advances in astronomy, planetary science, and cosmology of the last generation since the original Cosmos series. And I think it's clear, you know, that the first and foremost, the present Cosmos wants to try to reach people about what science is and how scientists thought and how they've been inspired in the past in various situations, and try to make a new generation of scientific thinkers, which is great. But it's really, I would say from my point of view, sort of shocking that it has not covered the astronomy that one would have expected it to cover. That said, nonetheless, we've got a lot to talk about here in terms of electromagnetism today. So what did you all think of the episode? How did it strike you? Any reactions?
Well, I think I had some of the same reaction that you did. You know, I think, I mean, to my mind, look, I agree with what you said. That, yeah, I think, you know, what Cosmos is going for here is really trying to help people understand the scientific process and their connection to the scientific process. And I think, you know, the name Cosmos, I think maybe, you know, drew us to expect something a little bit different than what it's turning out to be. You know, it's not Cosmos so much in the sense of being an astronomy show as Cosmos in the sense of understanding the universe of science that's around us. And, you know, once I kind of, you know, sort of reset my mental framework that way, I enjoyed this episode a lot. I mean, I thought, look, Michael Faraday is a fascinating character. You know, he was, a person who achieved incredible things with essentially no formal education, with very little mathematical background, and, you know, he had a very humanist approach to the sciences. I think, you know, a number of people on Twitter commented, and we were talking about this before the Hangout started, that you know, as incredible as Faraday was, and I would not presume to say that I'm anywhere close to his level of genius, but, you know, he was surrounded by other people who are working on similar problems. And, you know, I think this gets back to, I think, you know, one of the real contradictions of the show that they have not quite figured out how to resolve, which is, you know, there are two sides of science that they're trying to emphasize. The community of science, that there's this incredible chain of continuity of ideas, that it's many people working together, you know, mastering incredible insights into the world, and that is also a story of these very interesting, very personal, very colorful characters. And those two ways of looking at science are a little bit at odds with each other. And I thought, you know, this episode was a little bit at war with itself in that sense, that, you know, on the one hand, you have Neil Tyson telling us that, you know, if it weren't for Michael Faraday, you know, none of this modern world might exist. But at the same time, you know, Faraday was operating at a time when, you know, there were hundreds of different people who were fascinated by electricity, where there were many people who were working to invent an electric motor, to understand the connection between electricity and magnetism, and the show sort of name drops, you know, Ampere. It doesn't even mention Ørsted. You know, eventually gets to James Clerk Maxwell. You know, there was this incredible, very exciting intellectual ferment going on at the time, and Faraday was in the center of it, but he was not the only person. So, you know, I think that assertion that if it hadn't been for Faraday, we wouldn't have these things, you know, it's clearly not true. And so, you know, I think that's a very interesting thing that I hope, you know, people will take away from this show, you know, whether or not they respond to the individual stories, is that there really are, you know, science is driven by individual geniuses, and science is driven equally by communal effort, and that you need those two things together. You need leaders who kind of show you where to go, but you also need all that intellectual capital. And I think the show maybe does a little bit of disservice to the fact that, look, most of the people who are watching the show are never going to be Michael Faraday, or they're never going to be James Clerk Maxwell, or they're not going to be Albert Einstein. But there are very important, useful things that everybody can do, and, you know, especially now in the citizen science movement. And I just hope that the show doesn't, you know, discourage people from that side of it, from the communal aspect of science.
Yeah, I think it's a hard balance for the show to strike, because what hooks people is telling a story and, like, a narrative, and we're kind of programmed to like that, and in that sense it's much easier to tell the story of the one person than, I mean, if you had all of the hours of television ever and people would watch it, then you could tell the stories of all of the people. But it's hard, yeah. I think they're erring a little too much on the side of the one genius story. But I see what they're going for, and I think, I mean, from what I've seen on the internet, it seems like people do enjoy these stories, like they are interested in what's going on. And I do think this episode did a better job than some of the more recent ones of connecting the historical thing to us today, rather than just telling the story and like saying why this is significant for you and how this thing that happened so long ago still has these resonating effects.
Yeah, I'm kind of glad I'm going last here because I agree with all these shortcomings, as it were, of this episode. The lack of astronomy, the storytelling, kind of over some of the historical facts, maybe. But at the same time, I really did enjoy the show, and I think that the science part of me agrees and thinks, well, yes, there were things that weren't, super correct or a little misleading or whatever. But the storyteller in me, the person who likes hearing stories and being able to tell them, really enjoyed this episode. And I thought that it was a really nice. I'd complained in the past about some of the episodes being more kind of disjoint or scattered or schizophrenic. And this one was the opposite. If anything, like we're saying, it was too focused on one man, on this one guy's story. But we really followed his whole life. And that can be very satisfying, just as you say, Sarah, as a story. But through that one guy's story, we were able to get into all these concepts and be able to tie it into the present world and how important it is to the world at the time and how significant an advance it was. And being able to really tie everything in together so well that part of the story is the science and, vice versa. And I really enjoyed that part of it. I thought it was very well executed. And, certainly, like you also say, in the past, they've been doing this storytelling over facts a little bit. I remember when Robert Hooke was like a villain out of Central Casting in Shadow, and I think he had a hook hand. He was a bad guy. And, Davy here was not Mr. Nice Guy, but they were a little more tempered with him. And Michael Faraday was a little over-the-top good guy hero, Mr. Boy makes good, and that's nice. And, okay, that's not true. But it was still overall a really compelling story that got to a lot of super important points about science, about how things work, with, I think, one exception that we might be talking about later in this episode. But everything made sense, and everything was clear, and the science was coming out. And I thought it was a really nice turn for the series to be able to narrow its focus a little bit and just tell one story really nicely.
Yeah, and actually, I want to pick up on a little bit of that because, Faraday is an incredible character, and he may not have been the absolute, unvarnished, good guy that he was portrayed as in the show, but he was a pretty remarkably, like I said, kind of a humanitarian. He was a very moral guy. At one point, the British government tried to enlist him to develop chemical weapons in the Crimean War, and he refused. So he was a pacifist and a war protester in a sense. He was somebody who fought very hard for cleaning up London during the cholera epidemics, and was at times kind of ridiculed as being this kind of this ivory tower scientist wants to come in and tell us how to live at a time when a lot of people in London were living in really quite awful squalor, and he fought very hard to do that. So I think I'm now reacting against my own reaction, saying that I do think that the focus on Faraday, I think he's a fair person to single out, and especially the fact that he was able to do these things to get the public excited about science, to make these incredible conceptual leaps, to really use his position of power to improve people's lives and to take strong moral stances. Those are all things that are they're very relevant to where we are today, and remarkable that he did all those things coming from very humble beginnings, from very little education, really not starting with much of a leg up in the world. So there are a lot of inspiring things about Faraday's story. That closing quote is about nothing is too wonderful to be true if it be consistent with the laws of nature. I think that's one of the most beautiful summaries of how a scientist sees the world. But Faraday also had a little bit of a wicked sense of humor. I want to throw out this other Faraday quote. He was talking to William Gladstone, the great British politician who at the time was the Chancellor of the Exchequer in England, and Gladstone said something along the lines of, "No, so, Mr. Faraday, what good is this electricity that you're playing with?" And Faraday said, "Why, sir, there's every possibility that soon you'll be able to tax it." And that was like there's a guy who sort of who understood the world of science, but also very much understood just how the real world worked.
Well, and I agree with everything that you said, Corey, and I think by and large these things we're talking about are really not pulling down the episode. The episode was really, really well done overall. I'm just talking about, reasonably little thing. I mean, at the outset, the quotation that Neil said was, "If this man had not lived, the world we know might not exist today." The reality of the story is enough. We don't need to push things into being overly melodramatic. As you said, Corey, lots of people were working on electromagnetism with regard to motors at the time, of the invention of this. This was not an Einsteinian unique leap. Faraday was in the right place at the right time, despite his almost total lack of education, to do these experiments. But the world would have known electric motors from others had he not lived. So, and probably more or less in the same regime of time. So it just gets me that there's sort of this, we have to go just a touch too much here in terms of exaggerating things. The story of the reality itself is compelling enough. Can't we just leave it at that? And it bothers me a little bit that there's this sort of bending of things a little bit for the sake of storytelling when there doesn't have to be. That leads also into a question that's just popped up from Twitter. What are your thoughts on the portrayal of Humphrey Davy? They made him out to be somewhat of a villain, and I'll open that up to all of you here, but they conveniently left out the fact that, it was sort of Faraday's lack of acknowledging the help and assistance of Davy and of William Wollaston as well that sort of created this rift between the three of them. So it again, there is sort of a, making things out to be good and evil a little bit too much here, and maybe it's the cartoon style or the feeling that in order to make lots of young scientists, you need to have a good side and a bad side. I don't know. What do you think about that?
Well, look, I think if you looked at if somebody did a cartoon version of your life or my life or Bill or Sarah, somebody did a cartoon version of our life, and had to reduce it to 4 minutes, and had to decide which of the four of us who in this group is good and who is evil. I'm sure you could cherry pick and find things in the group that would make some of us good and some of us evil, and you could tell that story. And I think that's kind of what you're describing. When Cosmos is trying to present fairly black and white versions of these stories, it makes the storytelling clearer and more powerful, but it necessarily omits a lot of the subtlety of what real life is all about. Most scientific relationships, like friendships and marriages, are very complicated things, and when you reduce it to this, Faraday was right, Davy was wrong. There's a lot of stuff that gets swept by. Of course, and Davy, appears as such a peripheral character. You don't even really get to find out what Davy is all about. That that Davy was himself, an incredible experimentalist. That he had not just that one accident, but many accidents that left him debilitated from all of his chemical experiments. And one of his chemical experiments actually was that he discovered the effects of inhaling nitrous oxide. So he was the first person in history to get stoned on nitrous oxide. Look, there's not time to tell those stories in the course of the narrative, but there's a lot of cool stuff once you dig down.
Yeah, I agree. I think it's, again, kind of, if we had infinite hours to tell these stories, there is a lot more that we could tell to get into the whole truth. And whether the show spoke the truth and nothing but the truth, maybe, but it certainly didn't get to, the whole truth. And that's just how it has to be when you have limited time. I think TV tropes, a site I frequent all too often. The first one is flanderization. When characters who start out and they're somewhat well developed, but over time when the focus shifts off them, they become nothing but exaggerated versions of a few of their, characteristics. And so there's a tendency to do that in any kind of story that people tell, fiction or just an anecdote. Oh, that guy that cut me off in the street, he was the devil incarnate, he had horns, I hated him. Because it's just that's how we kind of work as human beings. And so, yeah, I mean, I don't think Davey, was really a bad guy in real life. I'm sure he felt justified in everything he was doing, and he might take issue to how the show portrayed him a little bit, just like any of us might in our 4-minute cartoons. But they made a conscious decision in Cosmos to want to tell Faraday's story, and so I guess they felt like they had to do it, from his point of view, and whether they took a few liberties that they should or shouldn't have. I mean, it still ended up pretty compelling, and I don't know. I guess I'm not quite as bothered by it as perhaps some of my co-panelists.
I think it's a little bit of lazy storytelling. I'm going to disagree a little bit, because I think it does do a little bit of disservice to the audience to say that you can't understand the nuances of human relationships. Someone has to be good and someone has to be evil, and you can't sort out the fact that maybe sometimes there's gray area in between. And there is limited time, but it kind of, to me, undermines my trust in the history that they're telling, because, obviously, in general, people aren't completely evil or completely good. So when you see somebody portrayed that way, I'm like, well, I'm going to have to go to Wikipedia and see what else of this is true after this, So I don't know how it has affected other people at large in terms of how much they believe about the history or don't believe. I don't know if you guys have seen anything about that.
Well, I don't think, I'm going to go on a limb and suggest that perhaps you might be in the minority for wanting to follow up on these things on Wikipedia, which is, I think that's a great thing to do, especially a show, and we have to remember this is on Fox, which is not known as the most intellectual network, we can say. I always enjoy seeing what's on right before Cosmos. Whatever Family Guy episode leads right into the show on science, where some crazy situation, and now some science. And so I agree that it is a lazy, it can be a lazy thing, and just perhaps suggest that they also know their audience, and they're happy to get a toehold in. It's such a balancing act, and so.
And let's also make the public service announcement that Wikipedia is not necessarily the world's authority.
Right.
Truth.
Well,
so be careful out
there. But that's where I do my research.
But it will tell you, though, about the interesting aspects of Humphrey Davy that were not discussed so much, as his work as a chemist, among many other things, and discovering, among other things, a number of elements, sodium, potassium, and calcium. So he was a pretty big deal in the world of chemistry, as well as electrochemistry and physics.
And he was a poet before he was a chemist.
Yes. Yeah. And let's just quickly, before we have a couple more questions coming in as well, but just to kind of continue in a logical direction for a moment, let's talk a little bit about James Clerk Maxwell, because here Faraday lacked the rigorous mathematical background, of course, but along came late in Faraday's time James Clerk Maxwell, and carried the ball and took the theory of what was happening farther. Does anyone want to talk a little bit about the great Maxwell?
I was a little bit surprised that the show didn't even flash Maxwell's equations, long enough to really see them. Since I think if you think of the equations that define modern science, Maxwell's equations and the equations of general relativity. There may be two or three others. Look, again, math is the very opposite of accessible storytelling. There's an old joke that every time you show an equation, you lose 10% of your audience, or maybe it's 50%, depending on who tells the story. But I think it's easy enough to look up Maxwell's equations, and it's actually easy to look up and find even a fairly common lay language version of explaining what Maxwell's equations do. But the fact that he had this incredible mathematical epiphany, where Faraday had these conceptual epiphanies, Maxwell had this mathematical epiphany, where he basically understood how three very seemingly different things were all linked together. Here you have electricity, you have magnetism, you have light. You put them together, and you not only explain them all together, but you find out, why does light move at the speed of light? The inherent properties of electricity and magnetism actually define why the speed of light is what it is. That to me is, that is completely mind-blowing. And even now, when I say those things, I feel like I still don't really understand that. How he came to that insight, and how and how those things all fit together into our world. That there is this grid of laws, and here's Maxwell out there finding that grid and figuring out that when you kind of bang at that grid, the vibration is what makes light. That is, to me, that's mind-blowing. And again, the show sort of ran out of time to discuss Maxwell, which is a shame. But there's a fabulous Maxwell biography out there. There's a lot of resources out there. So I hope, again, that part of what the show is if I quoting Carl Sagan, a candle in the dark, that it sort of offers some illumination to the viewers and gets them excited about finding out more of these stories.
Yeah, I thought it was interesting how the show was the transition was Faraday, he had these ideas and these abstractions, but he didn't know math, so he couldn't figure out these equations, but this other guy, he knew math, so he could do it. But you have to know a lot more than just math to be able to come up with Maxwell's laws. But I did think it was interesting how that kind of pointed out the difference between kind of more experimental science, where you're observing what is happening and getting this evidence for how the world works, and then the more theory side, where you're trying to explain why what you're seeing is happening. And now for the most part both of those sides involve lots of math, but you do need both of them, and theory without evidence supporting it is no good, and evidence without theory is just what's going on? So.
Yeah, I will say, to Corey's point, ever since they had that episode on Newton and they didn't flash up F equals ma, I gave up any hope of seeing equations on this show. Maxwell's equations did come up a little bit, very tiny. I think it was actually covered up by the hashtag logo and everything. But they came up for a second, and even that really pleased me. I was like, oh my God, there they are! So I didn't expect any kind of actual showing of the equations, and agree that is a tough thing to get into. But the idea of, this guy, he knew math, so he was able to do it. It also kind of speaks to, it was a little more than that. Since we were telling Faraday's story, okay, I can see why they did it, but that's one of those things that just he had a lot going on. He was the hero of his own story, and it is a shame that we couldn't get into that stuff. Maxwell's equations, I think they even look pretty. They're so elegant. It's so nice what he was able to do. And we've said it. It's a shame that we couldn't get to him, but an hour a show plus commercials. What are you gonna do?
Cosmos.
So here, let me give just a couple little Maxwell things that I wanted to get in. One is this quote from Maxwell, which I think really just epitomizes his worldview. This was from one of his scientific letters. He says that the true logic of this world is the calculus of possibilities. And you put that next to there's nothing so wonderful that it can't be true if it be in accordance with the laws of nature. You put those two together, and you get the two sensibilities. Faraday had this very, like I said, this very sort of humanistic and philosophical way of looking at the world. Maxwell was really trying to understand the calculus of possibilities that explains how the world works. And you need both those mindsets. I agree. It's a shame that we didn't get to see a little bit more of Maxwell's genius, because Maxwell, as they alluded, there's a reason that he was sitting, photo of him was sitting there on Einstein's wall, alongside Newton. Maxwell is, regarded as one of the greatest minds in the history of science. So if you're singling out, individuals who led conceptual breakthroughs, boy, he's really one of them. And the thing about Maxwell that I didn't know until I was doing a little background research for this hangout and after the show is that Maxwell was also a poet. There's a lot of poetry going on. Humphrey Davy was a poet. Maxwell was a poet as well, and he wrote this incredible poem. It's basically it's a love story told between two telegraph operators. And it's really you have to see it. You have to read it. It's called A Valentine to a Telegraph Clerk, Male, to a Telegraph Clerk, Female. And it's done in the sort of a romantic Victorian style. I encourage people to look it up and read it.
You're not going to recite it to us?
Yeah.
It's several stanzas, and I think it's not a terribly long poem, but I don't know. I think maybe maybe we have other things we need to do with our time as well.
Yeah.
But if you want to, I'd be happy to.
And if we run out of things to say, we can always turn to poetry.
Yeah.
Well, that was a very good discussion of a seminal moment when Maxwell came together at the very right moment with marrying theory and observation and produced a linkage between these different phenomena, which appeared to be different and unrelated, and made sense of everything working together. That was a major breakthrough moment because it's all related, it's all in the same universe. Now let's take a quick about face here if we can, because we've got some questions coming in. This one is from Kurt Weinberg. So, do you think animation helps or hurts the Cosmos reboot? And there was a lot of it this week, wasn't there? Thoughts?
All right, I'll jump in. I have to say, I was very much not a fan at the beginning. I did not like the way that the whole story of Giordano Bruno was told in the first episode, and I felt like the cartooniness of the storytelling kind of emphasized some of the problems we were talking about of trying to simplify and narrow down these stories to sell them to sell them in a kind of a slightly louder than life way. I've warmed up to it as the show has gone along. And as I've started to understand better what Neil Tyson and Andrew Ian and Steve Soder, the creators behind the show, what they're really going after, this cosmos is heavily rooted in the history of science, and I think the reason they're doing that is they're really, it's really not. This isn't a show about, so much about the things out there that we might explore someday. It's really about how we got here and about the intellectual process of science that brought us to this point. So, that puts you in a very difficult position, especially when you're dealing with characters from before the era of photography. Do you show fine art? Do you sort of act like you're, Ken Burns on PBS and you do a very, very slow zoom into a photograph? I think, look, they're in a very, very difficult storytelling proposition, which is you're trying to tell stories in which, there's often, limited real dialogue that you have access to, and very few visuals to work with about these characters, and yet the characters are incredible people. So I'd say as the show's gone along, I've increasingly warmed up to the animation technique, and I've just seen people reacting to it. Things that to me seemed a bit heavy-handed actually seem to resonate with other people who are coming to it with a little less background than I am, and that's what the show's all about. The show is about communicating the great minds of science and communicating the process of science. So I'm a reluctant convert.
Yeah, and I think if what they're going for, if what they want to do is tell these historical stories, which, as Corey said, you can't have these people on. Your other option is to have it be like some kind of true crime drama where there's like slow motion shots of historical reenactors and slow panning across empty rooms, and that's not as good as cartoons, I think, or of just sitting there while Neil Tyson tells us the story. So I think of those options, it is the best one.
Yeah, not to get against Neil Tyson and his gravitas and his enthusiasm, but we can't have a whole show of just him talking at the camera. And yeah, and so like, what else are you going to do? I with a show like this that looks to the past more than to the even the present of science and the future, what else could you do? And I never really disliked the animation. I thought it was weird at first, and we were all kind of surprised by Giordano Bruno and everything, but I mean, it's its own distinctive style. If I were to see, just a GIF or an animated GIF, or, a JPEG or whatever, just a tiny shot of something from the animated sections of the new Cosmos, I could recognize it right away now. There isn't much else that looks like it, and I think that's a useful enough, visual distinction that they were going for, that now that's theirs. And if they want to keep it going and have more seasons or anything, they have that. Or if it doesn't, and it's just a historical landmark, that's what it looked like. And I never thought it was weird or ugly or anything. It was a little distracting at first, but like we've all said, once you get used to it, you see that's how they're telling their stories. I think it's fine.
Hey, maybe they'll produce a graphic novel history of science. Maybe that's what they're building up to.
That would be amazing.
Wouldn't that be cool?
Yeah.
I would read that.
We're certainly not going to get the 18-year-olds with the Ken Burns effect in black and white photos, that's for sure. Not in this day and age. Now here's another question, this one from Michael Rath. What was it about that block of glass that caused Faraday to see what he did? So here we finally famously get to Michael Faraday, forced glassmaker. Reactions to glass and polarization?
Yeah, I actually thought the portrayal of that experiment, and it's an experiment that I'm familiar with, but it was a confusing portrayal, I think, especially if you don't have a background in it. So this glass was not just any glass. It was something called a dielectric material, which is full of these polarized molecules which have different charges, essentially, on each end. And then when you put that around a magnetic field, those charges kind of line up with each other instead of being dispersed in all kinds of random directions. And because of that magnetic field effect on the glass that the light was shining through, the light's path through the glass was affected. Is that you guys' understanding of what was going on?
I'm not gonna lie, I really didn't get it. I also know that experiment too. I know the concepts that he was talking about, and yeah. I mean, just seeing how they talked about polarized light at the beginning, and it was going one way, and then the filter, and then you could. Even that I thought was confusing, and I know polarized light. I've had to write about it way too much recently, and so I'm familiar with how you do it. And I was like, what is he talking about? And then the glass thing, like, they never said it was dielectric, right?
No, they just said it was glass, and
yeah. And it was just like a lump. I mean, I think that was the biggest fumble of this episode. That really didn't make any sense to me, and I like to think I know a little bit of science, so I can only imagine. And Neil himself lampshaded this, and he was like, "Are you confused? Don't be. Don't worry. It's a confusing thing." And it took them years to figure it out. I'm like, well, you're supposed to be explaining it to us, man. Why am I don't. So that's what I think of that.
Yeah, I agree. To all the other people who were confused, I think we were all confused too. It was just that was a place where I thought the show did not simplify enough and just was not clear enough.
No.
Okay, let's turn astronomical for a moment here and talk about Earth's magnetic field.
All right.
We have one. What is it doing? Why should we care? What about all these particles it shields us from?
We don't care.
You don't?
Yesterday.
I don't care either. I'd be happy to get rid of that magnetic field. It just bothers me. No, look, I'm gonna go on one of my little science rants here, which is. Obviously, you need a magnetic field. The magnetic field, the magnetic field creates a bubble that protects our planet. It protects the upper atmosphere from being eroded by the solar wind. It protects us from from particle storms. It guides the auroras to the poles, but mostly it protects us from radiation. It protects the atmosphere, the long-term integrity of the atmosphere, and everything we know says that you need a magnetic field to have a long-term habitable planet. Earth has a magnetic field, a strong magnetic field. Venus doesn't. That seems to be one of the significant differences between the atmospheric evolution of the two planets. So, what's weird and confusing about the magnetic field is there's really a lot that we don't know about it, including how much of a magnetic field do you need, and if it goes away for short periods of time, what actually happens. And the Earth's magnetic field goes through reversals, and it doesn't exactly disappear during reversals, but it goes into a much weaker and sort of less organized state. And yet, if you look at the fossil record, nothing much seems to happen. There are periods of hundreds, thousands, maybe even tens of thousands of years when the magnetic field is very weak, and Earth seems to muddle along okay. Actually, something even more confusing, which is to the extent that we're able to measure it, scientists think that the Earth's magnetic field was significantly weaker than it is now early in Earth's history, back at a time when the sun's radiation.
Did we lose him?
Uh-oh, did we lose Corey?
We might have lost him for a second.
We lost Corey. Yep. Any other thoughts on the magnetic field? We'll hope that Corey returns here.
Random fact about magnetic field switching is that when the poles are in the process of flipping, all these miniature north and south poles kind of pop up across the globe, and the field isn't as unified north to south as it is in that nice picture we saw in Cosmos, which is kind of interesting to think about, using a compass near one of those fake magnetic fields.
And I also just I think point out that back before December 21st, 2012, when that was going to be a big date in the future, and the Mayans had foretold something, right? That was one of the things. Earth's magnetic field flipping was one of the horror scenarios that was going to be leading to our doom, and people of science were like, no, it does that all the time, and it isn't a sudden thing. It's a gradual. So to echo what Corey was talking about a little bit, there is a lot that we don't know about Earth's magnetic fields, and there's a lot that non-scientist people don't know about magnetic fields. They have no idea about anything about them, and I wouldn't mind if we had another episode that got into them a little more. When Cosmos talked about the Van Allen belts, they showed the kind of classical like egg John kind of look, and even described them as donut shaped. But we had that look, and I said at the time, like, I wish we could have had the camera kind of go up and see them, from a different perspective, and see, I wouldn't mind a little more talk about what that was. But as it was kind of shoehorned in a little bit, Faraday's story. And oh, by the way, magnetic fields and science and Earth's dynamo is creating this, and that's cool. But back to Faraday.
Right. Also, wasn't there another Van Allen belt or another section of Van Allen belt discovered last year?
Yes.
Yeah, it was a brief one that came and went, I think, twice. Okay. So normally there's two pretty solid ones out there, right? And then turns out also maybe a third one. We're still just learning these things now.
What do you think about the way they worked in Carl Sagan this time by talking about the legacy of scientist communicators and those talks that were given? And Carl has made a couple of appearances with the bus and with Neil and other things in past episodes. I think it's really nice to kind of refresh that legacy every once in a while of Carl being behind the show. It looks like we're getting Corey back. We have Corey back. Excellent. Yeah. There he is.
Yeah, I'm not sure what just happened, but I'm here. Did I just blank out? What did it look like?
You just froze your image, and it was probably a cosmic ray, via the Van Allen belt.
Yeah, it was radiation wreaking its revenge on me.
You were right in the middle of something too, so it froze on your face, going. So that was amusing.
This one was saying that magnetism didn't matter. It wanted to prove that it did.
Well, so yeah, so what I was saying, and sorry to have missed the intervening conversation. So what I was saying was that there are many paradoxical things about the early Earth that we don't understand, including many things about the early Earth that make it seem like it was a terrible place for life, and yet there was life. It was a terrible place for by all rights, it should have been too cold for liquid water. There should have been very little ocean. There should have been incredible radiation doses, and yet somehow living things got started. So one of the paradoxes is back at the time when the sun was more active, it was producing more radiation, more charged particle storms. And back at a time when the Earth's magnetic field was weaker and offering us less protection, somehow life got started and life soldiered along through that. Maybe that's part of the reason why it took so long for multicellular life to happen in complex life. It's a story we're still just starting to put together.
Yes, and we do know that the sun long ago was relatively faint, and despite that, there was a liquid water environment on early Earth, which is surprising as well. And of course, the first life got going very, very quickly. We also turned to a question about Carl Sagan making an appearance again, Corey, in the episode as one of the speakers. And are there any other current speakers? We have a question who should make an appearance now in another episode who sort of champion science. I mean, there's Neil himself, Jane Goodall, Bill Nye the Science Guy. Is there anyone else who's sort of a voice of science who should be in an episode in the way that Carl has been? Is a question.
Well, I think another name I would throw out is Brian Greene, who is he's done a lot to popularize string theory and cosmology, and also is one of the prime movers behind the World Science Festival, which I think in some ways is perhaps the most significant thing he's done in terms of the public communication of science.
Brian Cox is also, I might put him up there, right? A literal rock star of science. In Europe, I think of him a little as the European Bill Nye, but he's still, he's in his prime now still. He still has his shows and things. So I guess I would put him up there, and he's a CERN researcher. He works on this stuff too, so people now.
And I think on a smaller scale, you guys took the famous people, but on a smaller scale, lots of scientists are trying to be communicators in general on social media or in outreach things, and I feel like it's a bigger deal than it used to be to want to convey what you're doing and why it's exciting and what being a scientist is like to other people. So there are tons of people who are not rock stars who are also doing good things for science communication.
And that's kind of a turnaround, right? It used to be more the case that if you were a real scientist, a hardcore scientist, you were supposed to kind of look down on talking to the public, right? And I don't mean like back in Faraday's day, but I mean like in the 50s or something, and that it was kind of like, oh, you gave a talk that people could understand. What's wrong with you? We will strip you of your academic bona fides now, because who do you think you are? And I mean, that's a bit of an exaggeration, a Cosmos-style exaggeration, if you will. But I think that, Carl Sagan himself, I think, bore the brunt of that when he was given some kind of honor. I'm messing up the details. He was given an honor, but with an asterisk, because he did all this public outreach, and he thought that was important. And the other members of the Academy thought, man, this guy wastes his time talking to the public. He could be doing important things. So the idea now that we have the citizen science kind of, let's bring the public in on one hand, and there's less of a stigma and even more of a prodding of, not even, like you say, not rock star scientists, just regular, everyday scientists going out in the public and talking to people. I really like that. It makes me a little nervous as a science journalist, because if they're any good, they're going to take all our jobs. But it's still a good thing, I think, for science, for people to know what is going on with these folks.
Mm-hmm.
Yeah. Oh, sorry, go ahead.
No, you go ahead.
I was just going to say, so, I remember, there are two events that I saw at the American Astronomical Society meeting. About 20 years ago, when I saw Carl Sagan, and about 6 months ago, when I saw Neil deGrasse Tyson, and Carl Sagan made an appearance. He kind of breezed into one of the sessions, and he offered some comments, and he was talking a bit about it was a discussion of exobiology, of sort of the chemistry of life on other worlds, and he made some comments, and he left, and there were audible snickers. There were people like, oh yeah, so he just came by to sort of like do his little thing, and he's probably off to some TV station now. There was like an audible kind of ripple of contempt. So this is not it was not a subtle thing. It's not a made-up thing. There really were a lot of people who sort of found his desire to sort of speak in front of the public, a little bit rude, a little bit sort of just kind of in bad taste. And then a few months ago, I saw Neil Tyson, and he was greeted as a star. People were mobbing him. They were excited to see him. They were excited about what he did. They wanted to know how he built an audience on Twitter. There was this incredible interest and excitement, and kind of adulation. And I think this was also among professional astronomers. This is basically the same group of people. There's been a real sea change, and I think it's exactly that reason why there hasn't been another Carl Sagan. There hasn't been somebody really of that kind of unique stature, because there are now many people who at a lower level are doing it, and there's a much wider acceptance of doing it. Back in the time when Carl Sagan went on Johnny Carson and would talk about science with Johnny Carson, a lot of people really turned up their noses at that and really consider that unseemly. Now the idea that a scientist would say, no, I don't want to be on Letterman, or I don't want to be on the Tonight Show, or I don't want to be on Nightline. It's just not what scientists do. That mentality doesn't even really exist anymore.
It took about 20 years too long in most scientists' eyes for them to realize where their funding was coming from and to do some good public relations. But as long as you're mentioning rock star astronomers and guys named Brian, each of which you mentioned, I'll mention Brian May as well, who's a reasonably well-known astronomer, but he's a pretty busy guy these days. Now, here's another question. What were the connections between class and ability to do science? Are they still there today as they were portrayed in the Faraday episode?
I'm not sure if that class and the access to science. Mm-hmm. Look, I think that is sort of that is a core human issue. That's something that will never ever go away. That some people have access to more resources, to better education. There are some people who just start out in life with a leg up. I think part of what was so inspiring about the Faraday story, I'm sure why they chose to spend so much time on it, is precisely because he was such a dramatic example of really starting from nothing, and making his way basically entirely on passion and intellect, and not on any kind of material advantage. Again, I think there are a lot of leveling forces. The fact that anybody with a cell phone and an internet connection has access to not only to Wikipedia and to all scientific research sites, but also the ability to participate in citizen science projects, as we were discussing earlier. Access to a lot of open source databases. There has been a dramatic leveling, and that as the technology has become cheaper and more ubiquitous, the differences between the haves and the have-nots have been getting smaller. But that said, there still are. Look, people who are well plugged into the research system and the education system, we know they get a leg up. If you look at who gets funding, there's a very strong connection effect, and there are still some gender and racial effects. So there's a long way to go. I think some of the leveling is going to be very, very difficult to do, because it's against human nature. We're trying to improve human nature, which is not an easy thing.
Yeah, I think some of the problems that were portrayed as existing in Faraday's day and having trouble from rising from his society into this kind of man of leisure, almost society where science was going on is still true, even with the leveling effect where, like, you can grow up in a place in a community where you don't know where to find the resources that are on the internet, or you're not, like, exposed to the world of scientists and science, and you have to go about maybe finding and penetrating that on your own, which is a lot harder than, like, you know, one of your parents works at this place and they do some science and they teach you stuff and encourage you to read stuff right from the beginning, and just kind of getting into that community is maybe a lot harder from outside of it than inside of it, I think, still.
Yeah, and I think, as Corey alluded to, maybe in our culture at least, class is still an issue, but it might be up there now with with the racial or gender disparities as well. That, I mean, there's certainly women and STEM has been such a big topic, and to another extent, you know, people of color, and Cosmos itself maybe doesn't have the best record on some of those fronts. I know they had that one episode recently with, like, all the women, and that was great. I haven't seen, I guess,
all many single ladies.
Yeah, presumably, yeah. And I haven't seen too many, you know, people of color on that show, besides obviously Neil himself. And not that, you know, they need to make it up if it wasn't there, but there's certainly people out there who will tell you that they had to overcome a tremendous amount, even today, to be able to make it, whereas other people, not to minimize their successes, but have gone through less in their life, however hard they work, to get to, you know, maybe the same place. So there's still, you know, like you said, it's human nature. It's going to be a while before we'll be able to make it, you know, an ideal society where everyone has, you know, any access, where it's a pure, who's good at science, you will rise up and you can help us out. You will be able to do this, as opposed to just kind of the luck of the draw sometimes.
Yeah, I think, I mean, look, again, another challenge with the Cosmos storytelling style is because it is so heavily historical, they're drawing from a period when science was incredibly dominated by white males. In Western science of the past 1,000 years, let's say, you know, is very heavily skewed toward the story of white male researchers. So if you're telling a historical story, you know, it's hard to tell that story without, you know, kind of embracing that skew. Yeah, I mean, and obviously, you know, Neil Tyson himself is the product of a different era, of a different possibility of achievement. But that, I think, is one limitation, that, you know, the show does not talk about current researchers. It does not talk about young researchers, and so, you know, there are a lot of really very encouraging stories that, you know, just are not appearing on screen. But I tell you, you know, again, you know, thinking about 20 years ago and today, of those meetings of the American Astronomical Society, you know, especially, I would go to talks, you know, the poster sessions or kind of young researcher talks, places where you see the graduate students and just, you know, the people who have just gotten tenured. The composition of that group has become so much different, so much more diverse in gender, in race, and an interesting thing is they've become a lot kind of hipper looking. I mean, it's a funny thing to say, but I think it's actually an important thing. It's no longer a group of people who see themselves as defined by being opposed to society. It used to be that there was a very strong sense that, you know, you would look at the astronomers, even in their early 20s, and they were, you know, they self-identified as outsiders, and they presented themselves as outsiders. And now, you know, they're tattooed, and they're sipping their lattes, and they look a lot like other people, which, you know, in some ways I think that's actually incredible cultural progress, which is they do not self-identify as weirdos and outsiders. They identify as people who are a part of the culture, and who, you know, in both ways, you know, they take the culture in, and they expect to give back out to it. And that, I think, is a fabulous thing. You know, I think we hear so many dire things about, you know, the lack of understanding of science and American, you know, the American public's aversion to science. But I think they're actually, you know, if you put aside the very politicized issues of climate change and maybe evolution, you know, if you look in sort of, you know, the broader kind of wonder of science type issues, which I deal with a lot in astronomy and physics, I think the level of communication, even the level of understanding, is really quite a bit higher now than it was, when I was a student.
Corey, you're not suggesting that I should pick up a couple of tattoos on the way home, are you?
I'm saying you need a tramp stamp.
I do think it's one.
You know what? I'm sorry, but we're just plumb out of time here. But this was a great conversation, and thanks to all of you. Thanks, Bill. Thanks, Corey. Thanks, Sarah. But that's all the time that we have this week for our Cosmos Rewind. A special thanks to Celestron for sponsoring these Google Hangouts. As always, we will be back next Tuesday once again to discuss the next episode of Cosmos, which is titled The Immortals. Thank you for watching. Have a wonderful week, and keep looking up to that cosmos.